literally going
what's wrong with
backwards.
that?
Who is they?
I'm saying the official reason for retrograde. I'm asking you if you know, according to the official way it's interpreted, is that it's because of the speed variance. We're going faster than Mars, and we pass it up.
You can have retrograde if you're faster or if you're slower. It doesn't matter. So the speed doesn't matter. It's just
okay,
that
fine.
we are in different
there's a speed
orbits.
variance then, right?
There's different orbits. And when we pass them by, we see that the direction of their, like the way we observe them.
Okay, I understand, that's not the real reason. And let me explain to you what the real reason is.
And you've got the other explanation with time or something.
No,
which has like
no, it's from, remember the old spirographs when we were kids? In other words, all you have to do is take a circle from your spirograph and move it along on a piece of paper while something is orbiting around it with a pencil. And guess what?
Get to you, which is like a very old, archaic methods of talking about this, and it was proven to be very difficult, very complex.
That's what retrograde is. Retrograde is when
that's why almost everybody who came after Ptolemy, single astronomer that came after Ptolemy.
No. Kepler wrote this out. Kepler, to his credit, before he fudged his data, a map of what Mars was doing in the sky and showing the retrograde loop.
Of course, everybody agreed on that. We agreed on that.
I'm trying to tell you what that's from, that there's only one way that
cycles. That's what it is. It's like a small, a good example, a good model, a good explanation, but it was inaccurate. Most of the time it was wrong. That's why Ptolemy actually corrected for Ptolemy. Because
you guys,
it was always
listen,
wrong.
Ptolemy had it right. Because an object that's orbiting Earth is being orbited by another orbiting object.
Okay. You know what's wrong with that model? You know what's wrong with that model? It requires that you have like this unseen other center of mass related to that object that rotates.
Yes.
That thing rotates around it. We cannot observe that. We
do observe that.
No, we don't.
Do. No, I'm trying to say to you that that's most likely what we are observing.
How can we observe it? Can you tell me how are we observing that for Mars?
Listen, Mars has no business being at that part of the sky and aligning with a star again 70 days early. It has no business being there. The only explanation is that the whole sky is turning. In other words, its orbit is turning like a wheel and it passes in front of our field of view.
We understand that. It just doesn't make sense because it requires that you have a center of like motion. It has to orbit something. And there is nothing for it to orbit.
Listen, it's orbiting the center of mass of all of the objects.
What center of mass?
In other systems. So why
it
are
doesn't
you
exist.
arguing with the
it
whole
does not
universe?
exist. We have tried to map that area to see if there is anything there. There is nothing there.
Okay, look.
With the telescope, there is nothing there.
We're not as smart as you're giving credit for your NASA. I'm trying to say,
not
why
NASA.
are you arguing?
No. This is way before NASA. This is like from Galileo.
Because that's who you'd go to for the data. Who else would you go to?
No. Just grab your own telescope and try to find anything near Mars that will force Mars to orbit it. There is no such thing. You are talking about an archaic idea. It's been debunked and disproven.
No, wait a second. Tycho Brahe said that the orbits of Mars and the sun intersect, and he was roundly criticized. They said, oh no, those objects will hit each other eventually.
Yes.
But guess what?
Yeah.
In the Tychos, they're orbiting at the same speed, so they will never hit each other.
No, it's actually, you can map it on a piece of paper and you can see them.
So let me prove to you that Mars is orbiting at the same speed.
They will cross.
Let me show you that Mars is orbiting at the same speed as the sun.
It's not.
If you use the lower bound number for its orbital time of 546 days, that amounts to 32 hours. If you divide that by Mars' orbital circumference, you'll get 107,000 kilometers per hour, which is the sun's speed. That's the speed of the sun.
Has a 2-to-1 relation to the sun. So it cannot be the same speed. I'm sorry.
I prove that it's not at the same speed. Look at how long Mars stays in each one of those constellations versus the sun. There are times where Mars is actually going backwards compared to these constellations. The sun doesn't do that.
But its orbit is twice the size.
It doesn't matter. In the Tychonic model, they will cross. They will go into each other.
So, Sam, just one second. He just said, one second. You just said that the orbit is twice the size. So if it's twice the size and going at the same speed, they would not. Now you can remove yourself.
Why would you say that if they're twice? If they're one's, it doesn't. It never takes Mars the same time as the Sun, so they wouldn't necessarily have to meet up. But as long as you mention that,
yourself, Hansbo. You can remove yourself.
As long as you just mention that, you're saying that there could be a cataclysmic collision between these objects. Now somebody ends life on Earth. Now watch that. Watch what's going on. Watch what's going on. Those are what you're doing is dot racing at the stadium. It's the same as dot racing. There's nothing about that you can prove anything with.
The orbits, the actual planets that you see here, there's a problem happening with them is that they are also orbiting something that doesn't exist. Their motion is not natural. There is nothing in nature that allows an object to orbit in that method.
Well, you haven't been introduced to how binary stars work because I'm telling you,
I completely know how they work.
I'm not changing.
We do not have a binary star here.
We don't see. In other words,
we do not have a binary star here.
Model that we don't see.
Look, there is no binary star here.
Binary, tertiary star systems are all. They're not stationary. They are also rotating. Not. They are also rotating around the center. It's irrelevant.
Of their galaxy. This is not a binary system. Okay?
That one is not.
Don't bring up binary stars when we don't have a binary star system here.
Well, he's trying to say Mars is a star.
Mars is a star. Mars is smaller than Earth.
No, I'm trying to say Mars is the sun's binary.
Mars can barely.
I'm not telling you what
little potato-shaped moons around it.
Let's talk about its moons and how its moons are timed with the sun's moons.
1 second. I came up to ask you to come back to one of the points that the Globerman has brought up that you completely avoided, the parallax. Because
I addressed it.
No, you didn't. I have already discussed this with you, and the existence of 2AU parallax proves that your model is completely wrong.
Can I challenge that scientifically by saying to you that your measurement is based on the assumption that we are orbiting the sun, right?
There's no assumption.
No. Yes or no? Is that how it's calculated?
No, it's not based on the assumption. We know
just
that we are.
Just a second, though. You have to start with a math number. How did you get that number?
One second.
And I'll tell you how you got it. You got it by assuming that the sun went 300 kilometers.
1 second, Hansbo. If I assume your model to be true, there should be no parallax between spring.
You say that?
Because you say that Earth is moving only 1 mile per whatever second.
No. What I said is in the same time span that your measurement was taken, Earth moved about 400 miles.
Yes,
and
that's not enough
it moved
for the parallax.
Opposite direction of what we assume.
Exactly. So it's not enough for the parallax. Congratulations, your model is debunked.
Okay, so what I'm trying to say is your model assumes that we made that motion, but you don't have any proof of that.
Sure we do.
Just a second, Senior, Mr. Avi. I respect you immensely. I want to know, and I want you to tell your listeners, please, how you know that Earth is going around the sun at 67,000 miles an hour.
Again,
please answer.
You go global. Yeah.
Yeah. So we can go back to Sir Arthur Eddington. He was actually trying to prove general relativity to be true with an observation. Right.
You're talking about Bradley, Sir James Bradley.
That's way older. That's
about Sir Arthur Eddington, 1919. I don't know what you're talking about. So he was going to prove, trying to get an observation to prove general relativity, and we're talking about like the bending of light around the sun. That's what he was going. That's what he was going. 6 months. This is kind of an unrealistic, that the light that's actually coming around the sun, the stars are identifiable, and they're completely different stars in the sky, because as we go around the sun, the night side of Earth is obviously on the outside of that orbit, not on the inside facing towards the sun.
Well, wait a second. Are you trying to say that we see
already know where the positions
hold on,
of...
I want to clarify what you're saying. You're trying to say that we see stars that we would not normally see?
Yeah, at that time of the year, you should not be able to see those stars because it's going to be daytime, obviously. But what you'll actually see is that since the sun is blocked by the moon right during this solar eclipse that he was observing, we're able to see those stars, and they're on the opposite side of the sun. 6 months
well, that's
later,
because it gets dark. That's
yes,
hold on, just a second. Hold on a second.
I'm almost done, and then you can talk.
Whether there's
Honey, I'm almost done.
You're making something very disingenuous.
I'm almost done, and then I will let you explain whatever you want. But 6 months later, because, right, those stars are on the day side, the sun is just eclipsed. 6 months later, on the night side of the Earth, if you look out at those stars, they're the same stars that were behind the sun during that eclipse. That means we're going around the sun.
Can I explain that to you in logical terms now?
Yeah,
in other words,
hold
just
on.
a second,
Just
though.
keep in mind,
We
you need to account for your claim that the Earth is being tugged along at 1 mile per hour.
Yes, exactly. In other words, in our lifetimes, we won't see any precession. It precesses like 51
This has nothing to do with precession.
Just a second. I'm talking about stellar drift, the stars moving.
I'm not talking about that.
Okay. So you're talking about the supposed precession that they say they can detect.
No. Here, I'll draw it real quick. I actually have something on my screen I can just draw with. John.
I'm curious as to why people are gifting some kind of weird model that's not even flat Earth, and I'm wondering who's gifting him. Is it flat Earthers gifting him?
No, it's random people in the chat who's gifting a large amount. I don't even care about that. So the sun is right here in the center.
People that don't like me because they don't like what I'm talking about at all, because it destroys their model. It completely not only destroys
which model?
It destroys the heliocentric model.
Hold on, honey, just look at my screen. Okay,
yep,
so here's the Earth, here's the sun. Okay,
this is not a flat Earth.
No, during an eclipse, obviously this isn't to scale, but during an eclipse, right, from the Earth's perspective, the sun is going to be blocked by the moon. Okay, during that time, what we can see is that on the opposite side, right, obviously over here, since this would be the day side for, roughly 6 months of the year, on the opposite side, we're going to have completely different stars compared to the night side, which would be this way.
And look at this animation. This shows you the actual seasonal parallax. See this animation that I'm showing? It shows the seasonal parallax, and it happens every year. And people can actually observe this.
And how many arc seconds of movement is that?
Very small. It's very small. It depends on how far you are. Some of them don't even have it.
Look, know what you're talking about.
Listen,
and tell them how many arc seconds are in 360 degrees. It's just so you know, it's over 1.2 million. And in our 1 year, we see it.
That's fine. We have the precision. We have enough precision to actually see it.
It matters because you're trying to make it sound like this movement.
Honey's boo.
So it is detectable. It is detectable. It is minor. And you see this one that is closer to us has a little bit bigger seasonal parallax, and it goes like in this small circle in the sky. The farther ones, the really, really far ones, they don't even appear to be moving. That's like almost over 1,000 light years or longer. We can barely detect.
You said they're doing a circle.
Yes.
Tell me about the circle and what could be causing that according to the heliocentric model.
Our orbit around the sun.
Guys, here you go. Here comes the wobble.
No. Our orbit around the sun.
Okay, same thing. In other words, there's no evidence that we're moving 67,000 miles an hour. None. They've tried for centuries to prove it.
Honey's boo. I was in the middle of answering that.
Yeah. Go ahead.
So again,
William Herschel, by the way, answered that.
Again, okay, I just made this even more simple. Let's just say in our model, this is the Earth's orbit. It's not perfect, whatever. Obviously, the night side during, roughly this part of the year is that way. And during this part of the year, it's that way. What I was bringing up Sir Arthur Eddington for was during an eclipse, he was able to see the stars that he should be able to see during this time of the year because the sun was blocked. The stars were visible. And then what do you know? 6 months later, during nighttime, those same stars that he was able to see during the eclipse, he was seeing at nighttime. The sun,
you know why?
Can actually,
I tell you why?
Hold on. The sun has a known distance. We can actually bounce radar off of the sun. There's been plenty of experiments.
No question. I'm not questioning the
distance.
I'm not questioning the distance to the sun.
Okay, so with that being the case, hold on.
Not the other way around.
With that being the case, that means we know that we are going around this object. We can't be moving one.
Let me tell you why you're wrong right now. The reason is because at night on the other side, those stars are still there, but they're just not visible because the sun is in front of them. Then when it comes back around,
daytime.
Hold on a second. 6 months later, the sun, supposedly we've come back around, but really we haven't moved and those stars haven't either.
Okay.
They're still there.
Hannesbo, it maybe it's a little bit more complicated, but here's another thing. Remember when I mentioned to you about the seasonal parallax? There's also a seasonal stellar aberration. It changes from season to season, depending on which direction.
Explain stellar aberration.
Okay, so when you are taking pictures of the stars, you will see a little bit of light bending a little bit in your equipment in one direction, and it's due to our motion around the sun.
Okay, stop.
It's one of the
stop. And the posited theory, that was Bradley. I said the other one when you said Eddie. Bradley's the one that posited. And go tell your listeners how he came to his conclusions.
No.
Without sailing in a boat.
Before Bradley discovered this, other people tried to figure out why this is happening, and the only reason for this to happen is because of our motion around the sun. There is no other explanation for it.
No, there is another one, but you'll have to keep.
The stars.
This is also an after.
And it's repeating exactly like
1 mile per hour retrograde orbit. So it will make a looping pattern over a year's time, and it will cause all the stars to do that.
No.
Because to his dismay, when Bradley posited, he found out that all the stars do that. Okay, now why would all the stars do that? Okay, now why would all the stars do that? Okay, now why would all the stars do that?
They're close to the ecliptic. They are in the direction of our motion. So we are. Hold on. We are moving. We are moving either towards them. Compared to that.
I explained that before. Some of the stars we're moving towards and away from, they don't precess.
I'm not talking about precession. I'm not talking about precession. I'm talking about stellar aberration.
The aberration is a loop in the sky. Hold on. I'm just telling you what it's from. It's from a loop in the sky that naturally happens in a year's time because mile per hour. That's what that is.
Why is it different for each star? Why is it our orbit around the sun?
Because I just told you, because some of them are on a different plane.
Fine. How about why do we have a different for the stars that we are moving towards versus the stars we are moving away from?
When you say Doppler, what are you referring to? You're credible, but might not. Let's hear about it.
No, the science will actually tell you that the speed of motion of Earth towards very near our ecliptic appears to be blue shifted. If we are blue shifted, but it is measurable.
I said that before. I told you why. It's because Earth is tilted, but it's not just tilted in its plane. my listeners. It's also, wait a second,
this is not related to Earth tilt. Hold on. This is not related to Earth tilt. This is related to the ecliptic. Not to the tilt. Not to the tilt.
1 second, Hanisbu. Blue shift and red shift cannot be caused by a tilt of Earth.
Yeah, it's not related to Earth tilt.
You do not understand
to proposed speed. Then what would make that?
We're moving.
What's the question? You said Doppler. This is a technology that they have inserted, which might be credible, but it might not. But I'm trying to say to you that in the type of stars are 40,000 times closer. And I showed you how.
It's a very simple thing.
Is not right. You're using the orbit around the sun as your measure.
Very basic. It's very basic. It's incredibly basic, actually.
Let me ask you a question. If we were going around the sun...
No, don't avoid his point. Sam, please.
And the moon were going around with us, why wouldn't we see parallax of the stars from month to month? In other words, we move 70 million miles.
Instead of asking more questions,
and your listeners will understand that undoes it right there. It can't.
So Bradley's observation, as you can see, this is Bradley's observation, right? And we do have explained by what you're saying. In addition, the actual shift can give us the speed. I hope you're not surprised.
Well, no, I'm just trying to say that what is that predicated on? That's
an observation. This is an observation, and we're open for you to provide your. We're open for you to provide your own. But the scientific community will accept it if you can substantiate it.
No, I think the observation. No,
Sam, I think the observation. Right now.
Let me.
I tried to tell you how the loops are created.
1 second.
We've tried that for 1500 years.
There's only one way to make the loops.
1500 years, people have been trying to, make those loop work.
Why doesn't the moon?
1 second, guys. It's a very basic question.
More questions.
Wait. One very basic question to see if you understand Sam's point. The sound of an ambulance. Can you tell if it's getting closer to you or further away from you?
Same thing for the stars.
What does sound have to do with the way? Have to do with the way? I just explained to you that Earth's 1 mile per hour motion explains the motion, aberration. And the official explanation makes no sense. It involves bending of light.
Closer or further away from you by its sound.
Yes.
Good.
To do with sound.
That is sound, but he was relating
it
it
has
to
nothing
light.
to do with light. Why are you bringing up something that we witness on Earth, and we're talking about something that's supposedly light years away, but it's not?
Tell me what the Doppler effect is. Tell me.
What? I mean, I just gave you the explanation for stellar aberration.
No. I want you to tell me what the Doppler effect is.
I don't know. You're the expert on Doppler.
Okay. Wait.
It's a speed variance.
Here is the Doppler effect. Okay.
Meow.
Very good. So
that's the Doppler.
Can you explain it?
No. In other words, you're just bringing up fluffy science. I'm trying to tell you.
No, I'm not bringing it.
There's an observable explanation that doesn't involve.
This is high school science, Hanisbu. This is high school science, Hanisbu.
From Earth.
Look. This is even known for AI, and I'm not saying that
I mean, you guys are more stuck in the past and flat Earth than the flat Earthers are.
This is the explanation that we have right now. If you have a better explanation, the scientific community is open to accept it. However, when you are measuring redshift and blue shift, speed your velocity is actually incorporated into doing that. And with that, you know how fast you are going. And it's not 1 miles per hour.
Here, I
I don't know how that's calibrated. So you're not. That doesn't mean anything.
It's simple. It's really simple.
Okay, so look, you guys. The bottom line is Mars reveals itself as the sun's binary twin by its orbit, which Kepler could not explain. So
can you do it?
Mars told him it was real. Mars told him everything.
Josh, could I have the big?
I told you already how he arrived at 687.
Honey, we just debunked you.
No, you didn't.
Honey,
you're bringing up something for a stellar aberration, trying to inject
you just
some
like the first time
technology
you hear
that
about
proves.
this. It's been 400 years in the making, and you just hear about it right now.
No, you're listening to fake experts that have been bamboozling everybody.
Fake experts.
Just listen.
Yeah.
I'm showing you how he related the two things. The Doppler effect. You understand it, right? As the object moves towards
I'm
you,
not there
listen,
doing. I'm not wearing a lab coat like you nerds.
Just listen.
And I don't think you understand.
Said you wanted to talk about the science. Just listen. Jeez, man, I'm trying to be nice to you. You're making this difficult.
No, what you're doing is you're pigeonholing it into this aberration, which I explained to you.
He's just retreating into himself. He's just entrenched.
So,
you never rebutted it. You didn't say why I'm wrong about that.
We're going to have this wavelength changing, right? The frequencies are going to be different in the wavelength. The same thing applies to light. We measure light in wavelengths and frequency. As the light comes as the object comes towards you or you go towards it, you're going to get different shifts in the color. That's all that he's talking about.
According to that. Okay. That doesn't take into account what I already said that debunks the whole thing.
You can deduce the speeds of the objects relative to each other based on that alone.
That's how we know that galaxies that are farther from us actually are moving away from us faster just by doing this.
Okay.
How much farther it is shifted towards the red or something. So this is
right.
Exactly
but it's injecting distance.
Hold on.
That's not
realistic. Here's the cool thing. It is seasonal.
Let me say that again. It's injecting distance that's not realistic.
Wait.
And let that soak in.
Just listen to this. It is seasonal. So this one star you check in September, in March, it has blue shifted.
Okay. It moved. Okay. It moved. I'm not saying there isn't movement, but the movement is grossly overstated. And the movement of Earth is grossly overstated because Earth only moves in that 6-month period. It only moves less than 400 miles.
Honey's boo. It's directly measured.
So you can measure that still. It's measurable.
You can't.
So there you go. There's your reason why there's a shift, because it did move. I'm not questioning that the Earth didn't move. I'm not a flat earther that thinks the Earth is stationary. I'm telling you there's a missing motion that explains the thing
3 times, man. I'm sorry.
And you guys have no answer. It's okay. I don't expect you to have an answer. Nobody else has either.
We debunked it like 3 times over here.
You've been given the
answer. It's retrograde.
You've been
and
given
also
the answer,
speed up in its orbit.
And you're just
only on its 8th time. Why? There's no way to reconcile that.
Hanisbo, let me just check if you understood what we said to you. If a star is moving closer to us, is it blue shifted or red shifted?
It's either going away or coming towards us, according to you. I don't know.
No,
but it doesn't matter because it's predicated on distances that are not accurate. It's predicated on the Earth going around the sun once again.
Don't crash out, man.
That's the math they use.
Hanisbo, that's not what I asked. I will repeat it, okay? If a star is moving closer to us, is it blue shifted or red shifted?
I don't know.
So you're trying to discuss something that you don't have even the basic
you're talking
knowledge
about
of.
using right, and I'm only saying that it's predicated and its math and data is predicated on emotion.
It's not
can't observe. In other words, the sun I'll put it to you this way: if we're going around the sun, we would see Mars retrograde every year, because we
here. So, if you hear the sound of an ambulance, can you tell if it's going away from you or
You're
closer
really
to you?
stuck on this. You're not willing to look at the physics and how the solar system is configured. You want to stay stuck on stellar aberration, which Sir James Bradley used a fake model back then to posit.
So, if you hear the sound of an ambulance, can you tell if it's coming closer to you?
We covered that. Anyway, you want to let another guest up because you guys aren't really interested in receiving new data. And the stars are binary. That's what the universe makes. So you need to know that.
Josh, your camera. Charles, I'll get you about your camera, Josh.
So, Hannesbo.
Bring up the model that I'm trying to say to you, and I'll explain it to you. Just listen. Just put aside your biases
just because
and thinking that you know something. I'm going to prove to you that the heliocentric model is wrong. I'll show you.
Don't crash out just because I debunked you. So.
No, you didn't debunk anything, brother.
So let me talk.
You brought up some fluffy math about for stellar aberration. It doesn't mean shit.
Can you provide?
You can tell that the ambulance is moving.
No, just let that other guy ask his question. You're stuck, dude. You're fixated on your aberration. You think that that's proof. It's not.
Let me talk.
Just let him finish, man.
Yes. So when the ambulance is getting closer or further away from you, you can tell it by the sound. Is that predicated on the distance, the velocity, or the apparent motion of the ambulance?
Yes, it's predicated on all three of those.
No, it's not.
It's predicated on the distance, the angle it's coming from, right? The speed. Yes, that's what it's predicated on.
For you to tell if it's moving closer or further away?
If it's going slower, but you'll hear it change faster if it's going faster. So what's your point about that, mister?
So you can tell the difference in the speed and the angle and everything.
Yes, on Earth.
Yes, it does apply because it's different. Waves.
Okay. So you cannot prove that the sun, that the Earth is orbiting the sun. There's no proof of that.
There's so many proofs.
Because if we were, well, hold on. If we were, well, hold on. Now, let's talk about Cassini. This is an experiment. Cassini sent his... No. You guys...
Honey Spoo, just let him finish, man.
No, he's full of shit, you know.
He's a professional. You're a fucking guy who reads Reddit. Shut the fuck up, let him finish.
What he does is he pigeonholes. He's not willing to listen.
That's great. Let him do whatever it is that you want to call it. Just have an actual conversation.
No, but explain Mars's orbit or...
Sure. We'll get there after he's done. Just let him finish his point.
So my point is that what happens to sound waves, and you just admitted that we can tell the speed, the direction, how fast it's going, is the same that happens with light. Those are waves as well, and the changes to wavelengths and frequencies follow the same principles of the Doppler effect that you see or you hear on sound waves. So I'm sorry, we can measure.
Okay, but your Doppler, hold on, let's talk about Doppler for a second, because that's what you're hanging your hat on.
I haven't heard Senor finish a point all the way through this. You fucking
No, but he's trying to say he's using a calibrate.
You can have your whole time and finish your whole point.
So, because this checks out, Doppler effect is a thing that exists, we can calculate the speed, the distance, how fast it's going, and we know it does not match your model. It simply doesn't. The existence of 2AU parallax is impossible on your model, so it doesn't work. Thank you.
All right, Honey's Boo, what is your rebuttal?
If you were listening.
You might not know he's muted.
I swear, he's not a real person. I don't believe Honey's Boo is a person.
Don't worry, guys. For his model to be true, we just have to pretend all of modern astrophysics is wrong.
No, I'm trying to tell you they hang their hat on Kepler, and he lied. He fudged his data.
Hold on.
And it's in the public domain. You can look it up for yourself.
Respond to what he said, not what I said.
Hanging your hat on data forged by Johannes Kepler, who forged his data. So he fudged it. And I'll tell you how he fudged it, because it goes back to 687, 707 times 7.
So you just need to avoid my point.
And it came out to 686.9. We will never see that from Earth.
Any proof?
Listen to me. We will never see Mars. An average because he couldn't figure it out. So he fudged. Donahue revealed it. William
Donahue. I don't know what your point. Can you respond to Senor's? Because Senor's been waiting for his answer for a while now.
I want to know why you think it's okay to fudge data. Why you hang your hat on it like it's gospel.
So
why would you?
You're conceding to what was said to you.
No, what I said about stellar aberration is that is the effect years time, because it's a looping pattern.
So you weren't listening.
That's all it is. I gave you the explanation for it.
When a star is coming towards us, whether or not there's a blue or a red shift.
I'm not questioning if stars are moving away or closer. All I'm trying to tell you is that math is calibrated on. There's no proof of that.
No, it isn't.
No, it isn't.
Well, look at that. That's what your stellar distances are predicated on. So yes, it is. That's what they're using.
One second, Hansbo. So I gave the ambulance example very slowly that even a child would understand, because that's not based on the ambulance orbiting anything.
Just please answer this question, Senior. Senior, can you answer this polite question I will ask you? Is the machine calibrated? Does that machine of Doppler that you referred to, does it calibrate it as though the Earth is orbiting the Sun?
Doppler is not a machine.
No.
Doppler
is the math used for Doppler calibrated calibrating the Sun? Yes or no? Which one is it?
No.
If it's yes, it's the wrong equation.
Just reply to you, and I'll explain it very slowly.
So there it is. There's movement. I'm not questioning. On to Mars now, right?
No. 1 second. Let me speak.
Let's move on to Mars, because you didn't answer how that can happen, and none of you.
Listen, it has nothing to do with the Earth moving. No one's worried about that. It has. No one's worried about that. It has to be between two objects. Holy shit.
Stuff that's very easy for him to understand, and of the celestial objects are constant, both on elliptic orbits.
He thinks the Doppler effect is fake data that you're working off of. Data that you're working off of.
He mentioned it's based off of trigonometry. What?
So he doesn't know, but he is really into this model. It's like his special interest. Yeah.
I mean, he mentioned that there was a common center of mass. I was asking him to show us a narration of his model. Does he have a narration? Reading a mass that we
Earth's orbiting the sun. You didn't even know what the Doppler effect was. You don't know what shift. So you also cannot tell on what it's based off.
I think he's trying to relate it to the stellar parallax thing, but there being a red or blue shift to the parallax, whatever the hell that means. I don't really know what he was getting at, if I'm being honest. If anything. Josh, more importantly, how come every time you bring someone up and tell me to have fun, it's not a fun time?
Did you enjoy it?
Yeah, kinda.
Oh, you didn't have fun with Hannesbo. He's one of my favorites.
I just don't understand how such basic concepts are so hard to understand.
So, Globe, you have to get away from the trying to explain something to them, because science deniers are never going to be convinced by logic. You just make fun of them.
Yeah, that's basically what my page has become.
Yeah, mine too. And yeah, I mean, I gaslight. I'm an asshole in my videos, but when I get on panel, I don't hurl insults, anything like that. I mean, we're in an academic discussion. There's no reason to get emotional.
Well, if he's saying that the distances that we have to the stars and other objects are incorrect, we're using the same principles to measure the distance to those objects, at least when we're, not physically bouncing like radar or whatever off of it. But parallax to determine the distance to the moon. In turn, you can use that to determine the distance to the sun. All of that would have to be wrong or just suddenly stop applying after a certain distance. But it's like, as long as the numbers you're plugging in are, they're not rounded way too far off into the distance, then it should be fine. So I don't get it. I mean, 18 astronomical units to the next nearest star, that would be ridiculous. That would be so easy to figure that out, because that's super close.
Hello, Boo Boo.
Is this the same person? Yes. No, it's not. Okay. It's like, is this a second account? I got scared.
I believe in the flat Earth theory, so.
Wait. You believe in a theory?
Oh no, not a theory. I think it's true.
Okay. Well, you just said it's a.
Irrelevant. Okay.
I think it might become relevant.
Earth is
That's
like
true. That's true. I was just
claim.
curious. I mean, she used the word theory, so.
Oh, no,
please continue.
It's a theory, so I just wanted to.
It's a hypothesis which cannot be repeated in any way, form, or fashion. It has no utility. But please continue.
So, do you believe in the flat Earth theory, or do you believe it's a globe?
My beliefs have nothing to do with anything. It is observably measurable.
So what do you think?
What?
I don't. I try not to.
Yeah.
I know the Earth is a globe.
Right.
You can measure the surface of the Earth and find out that it is curving.
The what, sorry?
You can measure the surface of the Earth to determine if it is curving or not. You can take two. This is the easiest way, at least in my opinion, to figure it out. If you want to measure it, you take two things that are plumb to the Earth itself, right? So 90 degrees itself, right? So 90 degrees. I'll say 1,400 feet. It's measurable in that distance. And degrees relative to the surface, they're not 90 degrees relative to, or sorry, they're not parallel relative to itself is curving.
Like measured,
What was that?
but when you
Yeah, so that's why we're measuring it. So this is within that 1,400 foot distance. You're only going to be able to measure arc degrees. So arc seconds, degree, right? 60 or.
But why does it have to be degrees? But why does it have to be degrees?
You don't measure it in inches.
How do we know?
You can do in inches.
How do we know?
You can do
How
more
do we know
difficult.
if
Gradients are good.
They are, but
we don't know that.
like I said, you can take
Well, you
two
do-
objects that
well-
are plumb, and they diverge away from each other once you set them a distance apart.
And the moon only faced one side. How can we not see the other side?
I don't.
Different sides.
You're then
Yep.
saying you can measure the globe, like Earth.
Yeah. You'll have a curvature rate, and you can extrapolate from there. Or sorry, you can from there. You can. So if you take, for example, the Verrazano Narrows Bridge in New York. If you take the Verrazano Narrows Bridge in New York, you have about an eighth divergence from the top of those towers. Just from that alone, if you were to use something like an auto, on that divergence. More importantly, you can also just use star trails.
We've never been to the moon though. So
Hold on, whoa. Before we jump to the moon, because that is what this live is about. But you wanted to talk about. So we agree that the Earth isn't flat. Then we got that.
No, but we can't.
Hammered out.
But listen, you're saying it's like a globe, okay? But from space, we haven't been there, and
we don't need to go to space to determine the shape of the Earth. But we did go to space to get to the moon.
No, I don't think so. That doesn't really like make sense then.
If you don't accept data from space, I can show you data from the ground if you want.
It's not a globe.
You see this?
Son of Africa, stop trolling. I know you're a troll.
Globe man.
Flat surface.
Globe man. I don't know how you haven't.
Can I get the box?
You're not a flat Earth anymore, globe man. You know that the Earth is flat. Why are you still speaking about the globe?
Son of Africa, I was on your live when I proved that the magnetic field of the planet cannot exist on a flat Earth,
You
right?
can't like repeat history.
So you see those two lines over here?
You might need to back away from the screen a little bit. It's hard to see.
Let me.
Oh my god.
Oh, there we go. Much better.
So, yeah, you see those two lines over here? Follow it.
What are they representing? What are they representing, those two lines?
Congratulations, you just saw the curvature of the Earth. Thank you.
That's literally freaking static. What the hell?
Curvature, bro.
You know how people do, like, when you have a baby and you do a ultrasound to check the baby before the birth? That's exactly that, but with the whole planet.
But there's no proof. Where's the proof? Where's the evidence?
Oh, that's proof. I just showed you.
Measured. How is that calculated?
Oh, the same way that you measure, like when the baby is inside, you bounce sound waves, the sound waves bounce, and you collect them.
Wait, that's scanning a mother's womb, right? But you're not scanning the Earth's curvature there.
No, that's the whole planet with sound waves. Yep.
What if it's refraction?
Yeah, exactly. It's reflection of the surface.
Refraction doesn't prove that the Earth is curved. Is that correct?
No, it does, because I showed you the surface that's reflecting and the surface is covered.
No. Refraction wouldn't prove if there's a curvature.
Reflect. You know when it bounces and comes back?
Right, that's why I can agree with that, but that's refraction. If light is bending down, right, that's refraction.
No.
You're presenting light bending down.
So, listen, when you're doing the ultrasound on a mom's womb, you don't put a sensor on her back to get what is refracted. The sound waves hit the baby and it comes back to the same machine. It's not refraction, it's reflection.
Earth is not a human.
Yes, that's refraction. But in a globe Earth, you're looking at refraction. If light is bending, hold on, sir, hold on.
I showed you reflection.
Wait.
Refraction is when light bends towards denser medium. Is that correct?
Yes, and he's using sound and not light. What are you not understanding?
That's sound. That's different. It's different from light.
Holy shit!
Light
exactly.
and sound, they're different things.
You're arguing. It's different.
Human.
No one thinks the Earth is a human. You have to be trolled.
Because that's the use of this technology that you probably have. Because it's the same technology and we can use it to see the entire planet.
I don't believe that.
It's kind of like how steam engines don't only apply to old trains. You could also use them for other stuff too.
That's refraction, and you're looking at the horizon.
No one was talking about that, son.
Man.
And also, refraction on a flat Earth, you would have a lot of different issues because you have to explain the pressure gradient issue. You have to explain how we're going to get the refraction index. Why is light bending downwards, making objects appear high? If you want to talk about refraction that do not work on flat Earth.
Well, Globman, refraction in your globe Earth wouldn't work because the ionosphere is much denser.
The ionosphere has nothing to do with the refraction happening on the surface by the horizon.
But how you get refraction if that's not the case, bro?
The ionosphere, the only thing that could be possibly related to, if you want to talk about the curvature of the Earth, is longer than line of sight, like communications, bouncing radio waves off the ionosphere. We're not talking about that. Refraction.
No, that's refraction. That's light bending.
You're moving away from my point, so I assume that I just proved it to you that the Earth is a globe, right?
You didn't.
No,
you showed refraction.
You know
I showed you reflection.
You know that refraction is not exclusive to a flat Earth, right?
It's also not exclusive to a human. What is happening?
Before you answer, cheers. And if you don't say it back, your mom's a hoe.
Cheers.
What?
Cheers.
What the hell?
Say it back. Just say it back. Just say it back. Trust.
What?
I don't know anything about
I'm
that.
not saying that.
So your mom's a hoe. Okay.
You don't want to say cheers? Damn.
No.
Okay, so
man.
Wait.
No.
Just one second.
Hold on.
Just one second.
Hold on.
I want one clarification on what you're speaking. Because you're saying refraction, so you are telling me that the sound waves are moving through one medium to the other, and they are not coming back. If these waves are not coming back, how were they detected on a flat Earth?
That's right. So you are scanning in woman's womb, you get a refraction on that. When you're looking on the surface of the Earth, you get refraction, not reflection.
You can get both,
right?
but
So
that's
it's
not
not
my
the
question.
same technology. It's not the same technology. It's
You
different.
also get reflection. It's a simultaneous thing.
You get both of them, but
Right.
that's not my question. My question is, you have your equipment on the surface, right? You send a wave into the ground.
Yeah.
How does the wave come back?
Well, your eyes in a globe model, right? Your eyes has to bounce. Hold on, Steve.
This isn't what you
Hold on,
sound.
Steve. No. Sir, ask me about the light, not about the sound.
No,
Steve,
I asked about sound. I asked about sound.
Sound.
Why are you talking about light again?
Bruh. Now, why are you confusing everything now?
I
Yeah.
asked about
The thing
sound.
that he showed you originally, that graph, was sound waves, and not light. We're talking about
Exactly.
sound.
I'll repeat the question
So
again.
why
Son of
are you
Africa.
invoking sound now?
Son of
You see,
Africa, think
light
earthquakes.
comes.
Think
hold
closer
on,
to earthquakes than refraction over the horizon.
So
We're not talking about that kind of refraction.
It seems like
The graph he
it seems like trying to get Sun off of his script. This is kind of like throwing a wrench in it. So please continue.
So
You're not getting off my script.
So I will explain how we got to this. Somebody said that, why are you looking at the sky to prove the shape of the Earth? And I said, I have data from Earth itself over here. We are not looking at the sky. And I showed you sound waves. Now, the question that I had for you, because you said it's not reflection, the question I have for you is, you have your equipment on the ground. You send the sound wave deep into the earth. How does it come back?
Well, speaking about that, you're not sending anything deep into the earth. The only thing that you have is what you call that, seismologic or something like that. That's what
That's
you have.
a wave. Yes.
That's what
That's
you have.
a wave. Yes.
Same technology.
It's not
That's
the
not
same
my question.
technology. No,
This
it's
is
not
the same technology, and that's not my. You are picking up waves with your equipment on the surface. Those waves go from the surface, pick it up. It needs to come back. How is
assumption that you are sending that there and then it's picking up everything?
It's an assumption that you're equipped to measure data. That's just made up.
Grobman, the only feather that we dig down was 8 miles, 7.
No one's talking
about
digging. I'm talking
There
about
are
seismic
different
waves.
methods to learn the same thing. We don't just have to dig a hole. There are other ways to do things.
So
I've told you, when you get him off script, he's going to go goofy. Keep going.
So
how far do I have to dig for, like, if I have to, like, loading in space under the disk?
Well, that's not 7 miles, Grobman. That's not
How
7
much
miles
deeper
deep
do I
down
gotta
the earth.
go?
I will explain very slowly for you, okay? We are dealing with a wave that travels about 10 kilometers per second, okay? This wave was caused by an earth.
How deep? How deep?
It was like 100. I am explaining something to you.
No. Okay, before you go further, how do you determine earthquakes and how deep do you have to detect? Do you have to detect that the earth is?
So, as this wave moves away from the source, about 21 minutes later, okay, have the same earthquake hitting the equipment again. The earth, you detected it at the surface, and after 21 minutes, you detected it. So what makes it come back?
Technology. You just detect what's reflecting back to you. Okay, after those 21 minutes, that's what you're capturing. Hold on, sir. On the surface of the earth, not deep down, not 8 miles down, deep on the earth, but just on the surface of the earth. That's when you detect that, oh, there was an earthquake. Now we get it 21 minutes after, just on the surface, not
very good,
8 miles deep.
Very good. So it's heating. Very good. So it's heating.
No. On the
very
surface.
Good.
Oh, no. Hold on, sir. On the surface of the
Fit
earth.
my narrative. Let me go back. No.
Yeah, exactly.
No, Steve, you got nothing, Steve. I know
Wait,
that.
son, did you just say maybe there was coincidentally an earthquake near the surface exactly that much later? Is that what you were just implying?
Well, the waves, we all know that when there's an earthquake, it's not going to be the
Does that
same.
mean yes?
Okay.
No, God, man.
You heard it here first, folks.
Yeah.
The measurement's wrong
we
because
all
an
can agree. We
earthquake
can
just so
agree to that.
coincidentally happened right when that wave should have been returning
Grobman,
based on estimates.
We can all agree to that, Grobman. Don't strawman me there.
Son
We
of
can all
Africa,
agree to that.
Wait. I would like to bring up the Mount Hungatonga eruption, in which the pressure waves went around the Earth like 6 times until they finally dissipated.
This one that I'm showing you here, they went around 5 times.
Okay.
It's obviously it was bouncing off the ice wall. Come on, guys.
So, Son of Africa, very quickly, just so I understand, you're okay with the earthquake happening, hitting something below and coming back. That's fine for you.
Whoa. When you say hitting below and then coming back, what do you mean by that?
I mean that it's reflecting on a surface.
On the surface.
On a surface.
Reflecting on the surface, bro.
Yeah.
You see that all right, I'm listening. I want to know where you're getting with this, because this does not prove that either the earth is a globe or flat.
Okay, good. So you do it once. After like 21 minutes, it's come back. Now it got picked by your equipment, let's say in the US. 21 minutes later, it gets picked by another equipment in Australia. Then 21 minutes later, it gets picked by another equipment in Brazil. Then 21 minutes later, it gets picked by another equipment in Europe. Each of the wave that we know, about 10 kilometers per second, and we know that because we have the equipment on the surface, can we tell the distance that it has traveled?
Yeah. Yeah.
Very good. So I'm going to show it to you. Okay. 1 second. You have this wave right here. Okay. And then 20 minutes later.
Hold on.
You have this wave.
You already showed that sound.
1 second.
Hold on. No. I'm not gonna hold on. You showed sound waves. Okay. You showed sound waves.
Right? Correct.
That does not mean anything. Sound waves may be delayed. Hold on. They may be delayed. All right. due to the medium where they're traveling through, right? So what you are showing, the sound waves, they don't prove anything. You have to show the actual radioactive wave which is within the ground, not the sound. Yeah.
Son of Africa, if I know the speed of a sound wave and I know the time it took, can I tell the distance the sound wave traveled?
You know the sound wave, which is different by the time which that thing occurred, right? That's different. No. Very, very different.
No, it's not. It's a wave.
Right, so, but the light...
Let me go again.
Light... Hold on, sir. Light.
I'm not talking about light.
Sound.
Why do you keep bringing up light?
No. Hold on. These are different waves that travel in different times.
Yes,
the speed of sound and the speed of light, they are different. You can't...
Exactly.
Right.
Correct. Yeah, correct. So this one is 10 kilometers per second.
That's a sound wave, right?
Yes.
Yeah. Do you know what?
It's not the actual. It's not the actual.
What is Mach 1, sir?
It's not the actual earthquake. It's not the actual earthquake. Hold on. Do you know what I'm saying?
It's the sound waves created by the earthquake. Yes.
But that happens after the earthquake happens. You don't know when the earthquake. You don't know when that actually occurs.
Oh no! The ground shakes. You're getting that on the newspaper, bro.
Yeah, I think normally when earthquakes happen, you'd probably feel it.
Okay.
Okay, like there's no sound in space, so how can you tell that it's like a globe?
Oh, but I'm not measuring space, I'm measuring the ground.
Right.
But how do you know if it's a globe then?
We just went over that.
Very good.
It was just explained.
So, we go again. If this wave happens in Japan and then it's detected in the United States, 21 minutes later. Then it's detected in Australia 21 minutes later. Then it's detected in Brazil 21 minutes later. Then it's detected on Europe 21 minutes later. If I know the speed this wave travels and I know the time, can I tell the distance? Yes. Now you're going to notice that the distance between two opposite points were always the same.
Flat.
What is the 3D shape that can have several opposing points to each other that are the same distance from each other?
Sorry, I didn't...
A sphere, thank you.
But, okay, so if there was an earthquake and it did hit Earth, okay, obviously it's going to shatter. If it was a globe, then how would we then obviously get intel from the other side of like the globe? That makes sense.
There is something called a seismic station, okay? And for this, we use it. Each single black dot is one seismic station. So for this, we collected data on every single one of these black dots.
Well, so what is that? Is that like intel?
That are seismic stations.
So, like, what does that do?
They collect seismic data.
Of what?
Of seismics.
What's that?
Sound waves going through the earth.
Okay. So
yeah, I just proved it's a globe and I show you the curvature. Thank you.
What if it's flat? That can be still flat.
It's not flat. Hey,
wait.
Why it's not flat?
Dude,
I don't know why it's not flat.
No, we don't care.
Explain.
Can you explain why plate tectonics and or magma rises using?
I was curious for the projection I was showing.
How do your volcanoes work?
Hold on. Optical has a question. Let him ask his question. That's what I was gonna say.
I was just curious about the projection you showed. Can that projection be shown as a AE projection as far as showing the stations and how the earthquake was mapped out, and how it hit those points, and how we can determine, the time differences?
Yeah, sure. So you see the projection. Here you have the earthquake location, okay? And as you go for the data, here you have the distance to the earthquake.
Can you big box him, please? Thank you.
Okay, thank you. So I'll go back. Here you have the earthquake location.
Projection is this that you have up there?
That was just for the paper. That is equal area projection, maybe.
I can plot points on an AE projection if we need.
So here you have the distance to the earthquake on the x-axis, and here you have the time for the waves on the y-axis. So for example, right here on 0, you're grabbing this wave on right here. Oh, let me close this window. Right here, you collect on the western coast of Africa. $150. And for example, right here, you would be collecting it at the ice wall on 60 degrees. You have also data from Antarctica over here.
No, I'm saying, is that what you meant? Is the Antarctic coast? Is that what you meant, though?
No, look, several data points on Antarctica.
Okay.
So for example, here, it's 0, and 160, not west coast of Africa and South America. These two stations here. So it happens here, the earthquake. 21 minutes later, you detect it both here and here on these two places. Okay?
Okay, so that's on the projections. That's what I'm saying. So as far as the globe said he can map those points out on the AE projection. So
sure. Well, which one do you want?
You want to see it on the globe? Okay, I'll show it to you.
No. It's not about showing me.
So
no, he wants to see it on the flat Earth, like the Gleason map. I'm guessing.
No, I got him. I actually have it pulled up already. So, well, which AE projection do you want to use? Because there's a lot of them. Do you want it centered on Los Angeles, Taipei? Where do you want it?
North Polar projection.
Okay, gotcha. Let me get that one specifically. I think I actually already have it.
So,
right here. Yeah.
This doesn't really work on a flat Earth projection because of the P-wave shadows, but that's a different thing. So you're getting here, then you're getting it 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 here. Okay?
You're assuming that.
It's cool.
Yeah, that's a diagram. The raw data, I have showed it to you over here. That's the raw data.
You're assuming that it's gone over the Antarctica.
No. You're collecting.
What do you mean? You're
collecting the data? You're collecting the data at the seismic station on that place, and then you're using the seismic data that you collected on that place to make this.
So, sir, do you understand that this wouldn't prove that the Earth is a globe? Do you understand it?
But it
would. It would prove that it's a globe, and I just proved it's a globe. If you want, I can calculate the size of the globe through this. You want it? I'll do it right now. It takes like 3 seconds. Takes like 3 seconds.
Specifically.
Prove that Earth was a globe or flat, because you
Where's that assumption? Where's that assumption come in?
Steve,
what's the assumption?
Can
Where does that assumption come in?
Because you have the mantle core and all that, which causes the earthquakes, right? And you can claim that, well, we don't have the mantle core in a flat earth, which would cause the earthquakes. So you're assuming that the mantle core and all that causes the earthquakes, and we wouldn't have that. The propagation, whatever is extended,
showing to you is that from one side to the other, it's 21 minutes. And then from another point to the other side is 21 minutes, and from other point to the other side is 21 minutes. And the only 3D shape that can fit several points opposed to each other that are the same distance away is a 3D sphere. If it was not a 3D sphere,
so sir,
you could not get it.
You see that? You're assuming of a 3D sphere.
No, the data is telling
telling him that it's a 3D sphere, son. You gotta understand. You're spouting off saying that he's... No, it's factual.
The data is plugged into 3dspace.com, which gives you that sphere. It gives you even the flat horizon. You can do that. That's just a data. It doesn't mean anything.
Son of Africa, tell me another 3D shape that you can have several points opposed to each other at the same distance.
Do you get all right. Valid question. When you have earthquakes, do you get them on the other side?
Answer my question.
No. You're assuming 3D.
Answer my question, son of Africa.
Sir, you're assuming a 3D.
Answer my question.
Oh, I'm not going to answer that because you're assuming the 3D.
No,
I'm not assuming.
I'm not going to answer it because you can't answer it, son.
No. He's assuming a 3D. He's assuming.
No, he's not assuming. It's factual.
Hello, my freaky darlings.
It's not factual. We see 2D, bro. We see 2D. We see in 2D. No. And he's assuming 3D. He has to face prove 3D.
Oh my God.
And then we move on.
Son of Africa.
Should we try something more simple?
You make me lose brain cells, son of Africa. I swear you do.
And this isn't visual data, it's sound data. It's not light.
How about something a little bit more simple?
Sound data is different though, Steve, if you speak about that.
You're saying we see in 3D
sound data
to do with light and
extremely
vision.
different.
Steve, we all see in 3D. You never see a curve over. You don't see a curvature, bro. We see in
Seconds
2D.
ago you said we see in 2D.
Son of Africa.
Saying we see in 2D, not 3D.
Son of Africa, I'll give you something more simple. I see that the seismographs and stuff like that, that's not the route you want to go. How about just looking at stuff? Does that sound good?
Well, that's as
you remember this? You remember this observation here where we had Ted Craig in southern Australia looking south-southwest, seeing Sigma Octantis. And then at the exact same time, we had... What was the other guy's name? I can't see.
No, Grobman, it wasn't
Craig,
the
I
same
think.
time.
Then we had Craig looking south-southwest at the same time by compass, keep in mind. Seeing the exact same constellation in the sky. So how do we have someone by compass looking this way and someone by compass looking this way, seeing the same object in the sky? And optical, this is on the AE map that you wanted, so I would love if you answered this as well. I can also pull up the video if you're interested in seeing the actual observation.
Right. The AE
As
map,
a
right?
equidistant projection.
Yeah, right. Thank you. Yes. Yeah. However, this guy, who's that Grover? I forgot his name. He didn't show that they're actually looking at that spot at the same time with a compass. You need to show that with a compass that they're actually looking at the same direction. No, they didn't.
He did.
No, he didn't.
I can pull up the video.
Yeah,
I got the Craig Jones Invitational on right now. Let me.
Right. So
do it.
You said they were both looking at the sky at the exact same time.
Yeah, well, it was a couple minutes apart because it was on a live, so he had to bring one guest up, but it was like less than 5 minutes apart.
Okay, and it was both at night.
Yep.
Okay, so
what
time of the what part of the year was this?
Let me see. I don't remember exactly the time of the year. It's on Globey McGlobeface's YouTube channel.
All right, yeah, that's Globey McGlobe.
Hold on, so
he didn't.
Real quick, hold on. So I just got a question. So,
right
would you
here.
would you think it was like later in the year for them? Like as far as maybe middle of the year. I would say summertime for us, like in the northern.
Yeah, so July 10th, 2022 for us. Yeah, I guess winter for them.
Yeah. Okay. So that would make
right
sense.
Here, this is Clint from South Africa. It's a little harder to see on his. He didn't have the same kind of setup that Ted Craig did. Here we go. All right, so he's showing by compass. This is him here. Okay,
no, hold on. He didn't show there what's the orientation? Was it south or southeast or southwest? Let's see that again.
It's southwest. So you can see where the red arrow is compared to where he was. Well, that's the actual Southern Cross. Before I lose it, this is actually good for me. You can see it. Here, I'm going to go back a couple of seconds. All right, there we go. That's the actual formation in the sky. We have the bottom cut off by the side of the screen.
Well, that's not it, Grobman.
It is. You can see actually right there, there's glare on the screen there, but there's the 2 pointer stars as well, pointing directly to it. So this is it.
What was he using? An app or what?
What do you mean? I don't know what kind of phone he was using.
So I guess he's insinuating that his phone is hacked by NASA or some crap.
Yeah, and then let's see the next one. So we can see this one was at 16 minutes 56 seconds. Here, we'll go to when he actually leaves the live.
Why would we leave the live for?
Just so we see the time in between. Okay.
No.
So right here, we can see that that's at 20 minutes 45 seconds is when Clint actually ends up leaving. Oh no, a little later than that. 23 minutes. And then Ted Craig, he ends up hopping in at 23 minutes 42 seconds, and he has a bit of a better setup here. So he's showing the actual stars here. You can see the Southern Cross. It's in a different orientation. Then we have the pointer stars here. And then if we go a little further, we can see he has his compass out, and it's looking south-southwest.
Okay.
So we map both of those out on the AE map. That's looking this way and looking this way.
Now go back to the other compass. Which side was he facing? The one before that? That's southwest, and the one before that. Let's see that.
Both are facing south-southwest.
He's got to get his phone set up. South-southwest. You can see north is down here. He's looking south-southwest, about 204, 203 degrees. And now watch hold on. Now watch where he tracks his camera, because he goes directly up. Right? See, that's his window. He's pointing it out. So he goes up from there. All right, it takes a second for him to do it. So he follows upwards, upwards, upwards. There's the 2 pointer stars.
I'm gonna have to
then he just turns ever so slightly to the right. And there's the Southern Cross. 1, 2, 3.
Where's the compass?
The other one's over here.
Where's the compass there?
He just showed you. Right here.
He showed it before.
Moves the camera upwards from there.
He showed the compass before.
Yeah, and then he shows you what he's doing. He's moving the camera upwards and then looking slightly right. He does it all very slow, so there's no trickery happening there. And we can see that would mean, again, on the AE projection, this guy's looking here, this guy's looking here versus on a globe. I don't have one on here. We'll just use literally any circle. We'd have an observer looking this way and an observer looking this way to the same point to see the same thing. So which one makes more sense? We look
the compass.
We
the
look
compass
both
it didn't
to
show
one.
it.
We look both to one point to see the same thing, or we look two separate directions to see the same thing. Which one makes more sense?
Or you have two observations.
So wait, son. Instead of just instead of just denying it, now's your chance to peer review. You do the same experiment. Get your own people to do those observations. Peer review. You have all of the method for his experiment.
Right. So
peer review. Do it again.
There's a difference.
Do it again and prove it wrong.
Oh man. So there's a difference in understanding and explanations between models, right? So as far as a flat Earth model, if there's a claim of a firmament dome overhead, there's an explanation of how you can look in the sky, and it could be some type of curving effect as far as when it comes to the stars. It could be one motion, but as far as
I think you got like a battery notification or something. We can't hear you.
You got a phone call or some such.
Oh, my bad. That was the battery. So yeah, it can appear to warp the stars, and it look like a circular motion. So
well, I'm not talking about a circular motion.
Explanation. Yeah, no, but as far as what you see in the sky, right? They're both looking southwest. That's what apparent to the star
But that's again assuming north is directly towards this north geographical point, right? Slightly off. I think we all agree that geographic north isn't exactly where magnetic north is. But either way, it would have to actually be in one of these spots. And that would mean that there would have to be some type of refraction allowing the light from this to do a 180 to somehow get to a viewer over, not even a 180, that'd be all the way around, damn near a 360.
Position between the observers, like as far as the person that's in Australia versus South Africa. Like in Australia, what's the angular position of the?
Don't know off the top of my head. If you go on like Stellarium or something, you can figure it out. It's for, what was the date again? July 10th of 2020.
Yeah, I remember.
All that data will be available there.
Yeah, I remember.
Data already, but okay.
He might have done it later on the stream. I can't remember. There was one point where I had it pulled up.
So, Globman, that's 2 points. Australia and South Africa. Globals, they claim 3 points, which is Australia, South Africa, and South America, which is impossible. You know that.
You could potentially get it. You would have to have like a real opportune time, but I mean, you're roughly cutting the Earth in half with the light.
Exactly.
It's going to be a little bright in one of the 3 areas. So I mean, you'd have to get lucky, but it's doable.
Because time difference. That's why it's impossible.
Okay. So why do we need the third point? There was no third point in the measurement. These two allow the AE map.
No, you actually have to use a compass properly. You see. Globfest, he actually didn't show the compass properly. The first guy, all right, he showed the compass with it. They saw it like that's legit, but Globeman, he didn't show that. He showed the compass and.
One second. For your argument to make sense, he needs to complete.
You can't do that.
I'd like to. I want to ask a question here, if I may.
Yeah, go ahead.
Hey, Globman, would it be like, in terms of getting the 3 points, his son is kind of questioning on whether or not we can get those 3 points in. Would it be better to do that specific observation? Would it be better to do if you had 3 points at the southernmost tips of each of those continents in, say, winter when it was tilted that way, or would it be?
I mean,
that'd be more.
It doesn't matter.
Yes, it would be best.
A question for you. It's for Glowman.
Yes, it would be best to do it that way, because then you would probably get the closest to full-on south as you can get with it.
Yeah.
But getting all three of those points in light at the same time is a little harder. You would have to probably go to the coast of either Australia or South America. It would be really hard to do it at the actual tips of them.
Yeah, but like, in terms of trying to get the points,
it's not impossible. Stop saying that.
It's not impossible.
It's not impossible.
You can't do it.
It's objective reality. South Africa. Stop fucking lying.
Time difference. That's what you. That's what you're missing.
No, it's exact same time.
No, if it's the same time,
I'm going to drop down easy. And allow someone else to join the panel.
Thanks for coming up.
Thanks. I appreciate it.
And Son of Africa. So, do you agree that around, or at least 50% of the Earth is lit up by the sun at any given point? At least 50%. Sometimes, if you want to count like light seeping over, like dawn, or like twilight, stuff like that, you can say more. But at least 50% of the Earth is lit up by the sun.
Yes, I can agree to that. And
okay, so that means all three of those continents, no matter which model we use, can be in darkness at the same time.
No, it's impossible for those three continents to be at dark at the same time. It's impossible.
Okay, son, we're gonna look at it together. I have it right in front of me. Let's go ahead and cut this in half. Let's start here, so we get South. Let's start here, so we at least get South America. We take it all the way across.
I'm not allowing that.
So if this half over here is in light, this 50%, that means this other 50% over here is in darkness.
Look at time and dead. Globman, look at time and dead.
The issue that we run into is that we're cutting it very close with at least one of the continents, meaning that there might be too much light to where you're going to be able to see stars, but it's not going to be officially daytime.
You are using an AE map. You look at time and dead.
That's what optical wanted.
Whoa, look at time and dead. Time and dead doesn't agree with the globe.
Time and dead agrees with the globe.
No, it doesn't.
I have a possible picture.
I'm not necessarily. That's why I asked you to take the time.
Master Blue has his hand raised. I just realized.
That's why I asked what the time.
Okay, let's get Blue in here.
So that would mean
here.
So as far as the evidence that I've seen,
let's get Blue in here for a second.
As far as seeing the light and how it can wrap around with some type of hemispherical dome or whatever.
No, I don't
need the light to wrap around if there's a local light source. So
optical. Let's get Blue in here. Blue's got a question.
South Africa and Australia, darkness at the same time.
Blue's got a question.
So this is for one of you two, either Son of Africa or Optical. I would really like you to explain this. This is a picture I took on my phone in Indiana while the sun was setting. Now, I'm going to test your cognitive dissonance a little bit here, okay? Can you tell me what would have to happen with the sun and that object to create this? What at a time would be preferable?
Oh, for me, I don't know that. I haven't done any observation. Maybe I'll let
you don't need any information outside of this picture.
No, Master Blue, I said it like
I don't care. You don't need any information outside of this picture.
I've never observed such type of phenomenon.
I don't care. I'm asking about this picture.
I'll let Optical say something about it.
Doesn't matter.
I've never observed any type of phenomenon.
Okay, what do you need to do? Because all the information's in this photo for you to answer that question.
Well, I don't know.
You're doing this thing where you're obfuscating from the question because you don't know. So I'm going to repeat it for you again, okay? It's very simple, Africa, so just shush and listen. What do I have to do with the sun and the object to create this shadow in the sky? All the information's in this picture.
Well, like I said, I'll let Optica say anything.
Okay, so
something
you're
about
dumb.
it.
You don't have an answer.
For me, I don't know. No.
Optical, what do you have?
I don't know.
Yeah, I know you don't know. Go ahead. Yeah, it's cool. Talk on it.
That's
so
a question.
Optical and I are gonna have a conversation on it.
Bro.
So shush. Okay, great. Thank you. You had your chance. So right here, you can see that it's deviating outward, which means that sun will have to be far away, right? And that object is now that shadow is growing distance. So it has to be below that object, correct? Because if not, then we wouldn't see the shadow cast into the sky.
Just apparent to be that way, it's at a distance.
How can it be apparent if I can recreate that right now in my room?
You can. I don't see why you can't. Right?
But the light source would still have to be below that object to cast it up onto the ceiling. So it's the same thing here.
You can create a phenomenal effect in that manner, yes, by having a light below an object and creating.
Not when it's directly in line with that object,
or
if it's above the object and it's still saying going to a focal point.
Like towards the surface that's in your room that's hitting the ceiling, yes, but also you can have light coming through the window and hitting.
Let's say I took this cup. Okay, this guy knows. Let's say we take this cup, we place it down, and you're telling me that if I'm above this cup with the light source, I can still do that and cast it up onto my
optica. You see that, Master? That's another straw man. Why using a cup?
It's not a straw man. You don't know what you're speaking about.
No. Why using a cup?
It's not. Why using a cup? Because it's the first thing I grabbed as an example. Dumbass, be quiet. You stay shushed over there, okay? You have no input on this. This is actually going fine with optical. You had nothing to say. No, you said you didn't have any answer because you didn't see. Shush, babe. Shh. You said to me that you didn't have, with all this information that you have here, okay, that you didn't want to speak on this because you haven't seen this in your...
You're strawmanning him.
Right, I'm almost done. Shh. Oh, babe. Shh. Okay, thank you. So you see how you didn't have any conversation on this when all the information was here in this picture, and you didn't want to talk on it? You don't get to speak on it now, okay? Great, thank you.
Using that?
Yeah, see ya, bye-bye. So optical, can you explain that for me?
You're muted, by the way.
As far as your observation, as far as the light below the cup, yes, you would create a shadow going upwards towards the ceiling in the room. Yes, I would understand.
So that exact thing applies to this too. The sun is getting lower than the object and forcing it into the sky.
Wait, hold on. That is an explanation for the observation, right? So another explanation. Disagreeing or saying you're wrong. That is the explanation for the globe, right?
And so that proves that we live on a globe because that can't happen on a flat Earth. If it was disappearing, hold on, hear me out. Because if it was disappearing to perspective, going farther and farther away in the same spot, right? There's no way you're casting a shadow into the clouds. What happened? Because then the light gets weaker as the farther it goes away, right? Because that means you can't see it. It's getting farther away from that object. There's no way that's going to happen.
Clouds, right? It could be a taller object that's above the clouds and the light is being obstructed, right?
What in Indiana
it would create a shadow above the clouds too.
What in Indiana would be so tall that's in the clouds?
I'm not sure what that is. I'm asking you. Is it? I don't know. I'm asking. What is
that? That is not in the clouds, sir. That is not the object, that building, that whatever
so what is
not in the clouds.
So what is obstructing the light?
Obviously a solid object.
What?
I don't know. I don't know
so
exactly.
It will be a tall,
hold on. Oh, sweetheart.
It will be a tall object, right?
No, it's okay. I don't know
tell
exactly
me to slow down
what that
is. Interjecting the whole time.
It is, but so that doesn't matter. Do you know? Hold on. Reel it back a little bit. It's okay. I got you. I don't need to know what that object is to know how that happens, right? So what I can tell you right now.
No, you got to know.
You're doing. Hold on, son of Africa. Hold on, dude.
No, that's a straw man.
You didn't want to have. You did not want to have any conversation about this when everything here to conversate about was in this picture. Optical and I have a great conversation. So I don't need to know exactly what that object is to know that it's casting into the clouds because the sun is lower than it. Like a light source and get farther away to where I can't see it, I still would not be able to see that into the clouds. It has to go the ground or that horizon. How can we have this happen?
Question. Like, what's that? And you just said you don't know. Like, can you explain that?
Are you just do you have like an issue where you don't understand what I'm telling you? You didn't have anything to talk about in this conversation, and you told me that you didn't know, so you didn't want to talk about it. So
no.
Why do you want to talk about it now?
You asked a question, and then you said that you don't know.
Son, why do you have to know what's causing the shadow? You just have to know that there's a fucking shadow there.
You have to know. You have to know what's causing the shadow, bro.
No, you don't.
No, you do not.
No, you don't. You do not.
That's why I'm saying this is trauma. That's why I'm saying this is trauma.
No, it's not. It's not. You want to know how I know?
Is that your go-to?
Light. That's all it is. This is a solid object. We know that for a fact. You see it going this way and that way, and that way. See it? You see that? See how we can see how light works because it spreads outward. It doesn't have it on a flat Earth, there, darling. It don't have it on a flat Earth.
Curvature? Where's the curvature of the Earth there?
Where's the sun at?
Christ.
Where's the shadow? Where's the shadow?
No, you know what? Son, we're done with
Where's
you.
the shadow?
No, son.
No,
Sweetheart, calm down.
Master, hold on.
It doesn't matter.
Master.
I don't care about the curvature because that's not what we're talking about. We're talking about where the sun needs to be placed to cast a shadow into the sky.
But
you're not obfuscating from this. I don't care. Don't care.
Bro.
Great. Don't care. Keep it quiet over there, buddy.
Optical, if you need to know what the object
can't just say you
this
don't
is the
care,
same
bro.
thing.
Oh my god, if I was a mod, I would have shut you up, dude. Be quiet. No one's talking to you.
Mr. Blue, 1 second. Are you on the south part of Indiana?
I am central. No. Well, where that picture was taken was just west of Indianapolis.
West of Indianapolis, okay.
In optical, if you need to know what the object is, this is a picture of the same thing happening where Mount Rainier is the object creating the shadow. It's the exact same concept, just in this one you see the object blocking the sun.
Where's the curvature of the Earth on that
You're
object,
an idiot.
bro,
We're not talking about that. No one cares about what you're asking right now. No one cares about the curvature. Because guess what? Son, you're trying to run because you have no answer, right? You don't care to listen to what you have to say because you have no answer. You keep saying, where's the curvature in the picture when we're not talking about curvature? We're asking about where the sun is placed. So until you have the intellect to understand what we're talking about, be quiet there, sweetheart. Be quiet, okay? Those lips are moving and you're not listening.
Where's the curvature in the
it doesn't matter. We're not talking about it. It doesn't.
You're saying that's an object.
No.
It doesn't matter. You see, you're saying that it
matter.
doesn't
We're not
matter.
talking about
Why
it.
not?
I can show you.
Don't understand what's being asked.
Y'all kind of missing it,
right? No.
I just
It's
wanna
very
confirm.
simple. It's where is the sun placed is all I'm asking. I don't care about curvature. I don't care about it being flat, round, whatever. I want to know where the sun is to make this happen. Very simple. And you two can't answer it.
Sun and optical. Do you know what causes shadows?
Told you it's at
Go back to step one.
greater distance than you. The sun will be local.
Sun and optical. What
Right, the
causes
sun
shadows?
is always in the sky.
My
above
phone
the
is shutting
clouds.
down.
What causes shadows?
Obstruction of light.
Right. So it doesn't matter what the object is that we know that how shadows are caused.
Okay.
But I have the object if they want.
So it doesn't matter, right?
I'm not even asking that. What are you talking about?
But you did say I have to know, otherwise it doesn't work.
No, I
You
didn't
said
say
it.
that.
Maybe
I didn't
Son
say
of
that.
Africa did, but one of you did. Said that I have to know what this object is to know.
No, I don't. I don't know. I know it. I have to be something tall. Obviously, that's above.
I have the object right here for you.
It's a
Mr.
tall
Blue.
object.
Mr.
Apparently.
Blue, the sun was setting southwest, right?
It was setting. It was looking due east. East to west, west to east. Rising east, sets in the west. It was looking west.
Southeast?
Yeah, I was in Whitestown, Indiana.
Okay, so listen, you have a mountain range right here. Indianapolis, okay, a little bit to west, and on the direction that you're looking, a mountain range right here. Okay, that's the object.
Now we know it's a mountain.
So, Blue, to confirm, this is a sunrise.
Sunset.
And if you're interested in how this is at all related to the shape of the Earth, your two options are the sun is getting lower than the object itself to cast the shadow upwards on a flat Earth, or the Earth has rotated object that is casting the shadow upwards relative to you. Those are the only two options. There isn't anything else. You could say there's water reflecting. There's not enough water there to reflect an entire mountain range onto the clouds.
Yeah, in the middle of Ohio.
Mm-hmm. By the way, Ohio does have small mountains. I didn't say that had to be in Indiana, by the way, because I'm not that far away from the border. So if you're like an hour's drive from the border, an hour and a half away, you can still see things that happen in the next state, buddy. TM, okay? So sit down and let adults speak.
So I mean, those are two options. Either the sun has gone below the mountain range physically on your flat Earth, or the Earth is rotated.
And every time I try to speak and explain to you the flat Earth position, in a sense, right, you cut me off. So what I'm saying is, if the Earth right? For the flat Earth cosmology, the sun will be local and it'll be at a greater distance. So the object that's above, that would be, the peak of it would be above the clouds, right? And it's hitting, and then the light is at a greater distance beyond that, and it's still, enough to illuminate beyond that to create a silhouette within the clouds. And based on your perspective, it appears to be going up, even though it's going straight over your head, right? Because the whatever that is, that tall object obviously is erected above the ground.
The Mount Rainier one I showed, it was completely below the clouds.
Image. So as far as that, yes, it appears to be going towards the horizon, angularly down, but it's just going straight above your head. It's just perspective.
Wait, why do we see this then? You can look at, again, using perspective. We see the mountain is making this sorry, I'm on the smaller screen. The mountain is making like this this triangle shape, but in the sky it's this upside down triangle. That means it's being cast upwards. Our perspective tells us that. If it was the other way around, we'd be getting this same shape projected onto the clouds the other way around.
How a shadow appear to be casting upwards, right? But it's not. It's just, well, now I don't say it's not, right? That is a explanation for the globe, right? For a flat Earth, it would just appear to be going up when it's just going.
Get my light.
But that also assumes
real quick, and based on that angle, and based on that angle in this image, right, is you can tell it's not on a straight angle, right? So it's like off to the left somewhere. So
okay, here's a better one where we're more centered with it. Same thing.
Let me see if I can make this happen.
And it appears to be even more going straight over your head, right? But it's just perspective where it's appearing to be fanning out. But it's just straight, right?
I'm gonna turn off my green screen and show you. I'm just gonna recreate this right now. Hold on. It's very simple, dude.
The question:
how is the whole peak is below the clouds?
Hold on. To let you know this, if this is a live video, if he was to turn around, it would appear to converge to the horizon and close in.
Okay.
Right.
Let me know if you guys see this.
It continues fanning out, but I wanted to say this also isn't going into.
It would converge back in if the observer turned around.
This isn't going into the clouds. This is actually just what the peak of the mountain looks like. And then if we look at these other images, we have the same peak. It's not going into the clouds.
Peak is above the clouds.
So look, see this?
No, it's
my
the
light
same
source?
outline.
Okay, I'm gonna put it right next to my phone here, so we know they're right next to each other. Okay, see that? Oop, I accidentally turned it off my fold. Boop. There we go. Okay, it's back on. I'm gonna try to do this with one hand. Okay, I'm gonna try to do this with one hand. Work with me here. Okay, so I might not be able to do it that way. Give me a second. Okay, I'm just gonna post you up right here so I can kind of see what's going on. Okay, sweet. All right, so if we take this, okay, and you see how it's casting a shadow on there? The greater the distance is, see how it gets smaller? It's not casting up. That casts down. That casts up. The light source needs to be below, down here, right? Boop, 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 right here. So it needs to be down here to cast a shadow upward. There's no way that the picture I'm showing you has something that's equal or higher than it, but farther away. It can't happen. That cannot happen. That light source needs to come down. How does that happen on a flat Earth?
Does this work with objects other than geek bars?
It can.
Okay, all right, just making sure.
So explain that to me, right? I just gave you a perfect example. A perfect example. So can you explain the optical or no? I'm making so much noise.
You explained it for a globe, right?
No, I explained it through the process of light and what we're seeing.
Right. So
so it poses a problem in your model, where the sun is
from above, being casted in and creating shadows above the surface.
Okay, but what I don't think you're understanding is, I don't care if it makes it a flat Earth or a round Earth or whatever. The point that I'm making is your sun is not where you say it is. That's the big key, right? So we'll break this down to the very bare minimum of what I'm talking about. Your sun cannot be in the same place, getting farther away,
because it would not recreate exactly what I showed you. The sun needs a new place. It needs to get below something. So either on your map, your model, whatever you want to call it, the sun dips below something, or it gets closer to the horizon and gets wavy.
Can I ask you a question? So about that observation that you put up, you would, so the sun is below the horizon at that time?
It's getting below the horizon, yes.
Is it below the horizon?
I couldn't see the sun, but it's reaching to go down below the horizon. You could tell by the color of the sky because the orange and the radio scattering.
So what would you assume it is positioned at if there was no...
Lower than the object, then that is casting into the sky.
So if you can't see the sun, so you're assuming it's below the horizon?
No, I don't need to assume. There's two things we don't need to know that I don't need to see exactly. Hold on. I don't need to know exactly where the sun is, and I don't need to know what that object is. We can know that the sun is. Hold on. We can know the sun is lower than that object because it's casting a shadow into the sky. Do you understand that?
Right. So I'm asking you a question. Based on that observer's position, if there was a flat ground and you could see out to the horizon, do you think the sun would be below the horizon?
No, it would not be fully below the horizon because then it would be dark.
So it's still above the horizon.
Yes, either partially still above the horizon or just above the horizon. It is not fully below the horizon.
And you assume that like the sky that the observer is in is a bit dimmer than
it's
normal.
not an assumption. No.
He is the observer, by the way.
Yes,
in the photo.
I am the observer.
So it was dimmer outside, right? It was later on in the day.
This was sunset.
I was about to ask, have you seen a sunset?
I'm working on it. One of these days I'll build up the courage
to go outside and see one. I know they're scary, dude.
I know.
It was the first time I saw one. I was shitting my pants.
Where does it go?
No, it's scary, dude. I hope it comes back up. You know, I never know.
Yeah. It has most of the time, but what if one day it doesn't?
Darkness for everyone.
He sleeps between sunset and sunrise.
How many sleeps?
God damn it.
I don't leave my my house.
Or sleeps.
So optical, that it really does come down to, does the sun go below the object and the earth is flat, or is the earth just rotating? It's either the sun is physically lower in elevation than the peak of that mountain, or the earth is rotated. Those are really the only two options. There's not a large enough body of water to cast that shadow upwards. The ground isn't reflective enough to cast that shadow upwards.
It wasn't the moon.
There's only two options there.
Yeah.
Blue, do you have the exact date of that picture?
I do. Stand by.
As far as the light source, it'll appear to be
3rd at 8:34 p.m.
So it'll appear to be
which month?
Based on the intensity
August
of the light.
20th. Oh, hold on.
August 23rd. Okay.
Yeah, at 8:34 p.m.
Optical.
Now, optical.
Does light travel in a straight line?
Okay.
Unless it's affected by something, does light travel in a straight line?
Yeah, so as far as the sun being, as far as a flat earth, y'all keep explaining over and over and over and over.
Answer my question.
So I just want to, get my thoughts out without being
a simple question. Does light...
Hold on. He should be able to answer. He was asked a question.
Unless obstructed, does light travel in a straight line?
This guy keeps talking over me. See, he just came on stage. He just got here. So what I'm saying is, as far as a flat earth cosmology, the sun would be local and appear to be farther away based on the intensity of light, right? And yes, and it's casting a shadow because the peak of the mountain or a tall object is obstructing the light and casting a shadow above the clouds. And it's obstructing light for the observer below the clouds.
So you just believe that the sun is high in the sky and just can magically grow distance and cast shadows into the sky. You understand what you're saying, right?
93 million miles away and it's below the horizon and casting a shadow up.
Holy shit.
Like,
yes, because the Earth rotates. Keep in mind, optical. The Mount Rainier one I showed, the peak is not going above the clouds. The clouds were all above the mountain. I showed you the peak when there were no clouds. Then I showed you when there were clouds with that shadow. And the whole peak is visible. There's even actually a point where it disconnects. The shadow isn't even touching the mountain itself.
Yeah. And
so that means that it doesn't start at the same point.
Mm-hmm. And before I bring up the picture again, like actually, if you look at what Patrick has,
and there's from above Mount Rainier as far as the peak, and you can see the light and the mountain peak obstructing the light.
So
here's the thing, though.
At all times, the sun is in the sky above the clouds.
Even with your theory of where the sun is, look at Patrick's picture. Okay, I really want you to understand this.
That's what you're claiming.
Why we know? I'm going to tell you why we know, and what. Before pointing in the sky, staying at the same height. Look at Patrick's picture. The bottom is dark, the middle is orange, the top there above the orange starts going to yellow before it goes white. That happens because the sun is setting behind something. As the light travels through more atmosphere, the more red and orange that light is going to get, right? Because of just how wavelengths of light work. So it's dark because at the bottom it's being obstructed by Earth. It's at the horizon, therefore it is orange. Then you get as it grows, the gradient of less obstruction, right? You get that yellow, and then white is because that sun is just ripping it up. The higher it goes.
Nava might be able to relate this to chess for us somehow.
Oh yeah, get a chess. I just wanted to...
on the observers,
So this at the beginning of this book,
it's at a greater distance, right? But the sun is still at a distance where the sun can light up that area, right? It's just at a greater distance than the observer. That's a great image to me. So I see it in a different way than you do. You just assume it's below the horizon and it's the light shining up, when the light should just be cut off because it's at a greater distance, right? So as far as even where's the curve of the Earth in the image that Stash's PFP?
You don't need to see curvature to know where the sun is, dude.
So it appears to be flatter now, right? So in the distance. So where's the curvature? So in this image,
dude,
is the sun below the horizon?
Yeah, real quick.
You asked me this already.
It appears to be, right? It appears to be below the horizon already. For you, right? It appears to be below the. So do you think it's beyond the curve of the Earth right now?
Stop.
And shining the light up.
So that's what has to be happening, is it needs to be below that object to cast a shadow upward, right? I don't need to know that it's fully set behind the horizon. I don't need to know what that object is. Would you stop and wait, dude? Stop. You can't bitch about being interrupted if you interrupt other people, okay? That's just how that works. So I don't need to know if the sun is fully behind that horizon, which it obviously isn't because I'm still seeing red, okay, or orange. But I don't need to know that it's fully set, and I don't need to know what that object is to be able to know by very simplistic shit I've learned in 4th grade, right? That the light needs to be below that object to cast it up. I don't care what I don't care what you think, what you may say. It has to be below that object. Doesn't matter, end of story.
And real quick, this will kind of align with
end of story when there's an alternative explanation. So no, so that's ridiculous. That's not.
It's not. You're just wild intellect.
I'm sorry that
that's what you call.
I'm sorry that the start of your sentence interrupted Nava's.
I'm not. Hold up. He was talking to me, and I get to respond. Come on, y'all.
No, you don't. Nava had a question for you too.
I don't care about who got a question for me when Master Blue or Stash was talking to me. I don't care about who has a question for me. When somebody was talking to me, I get to respond.
How do you feel about not interrupting people and let Nava ask?
How about you just?
Real quick, I was gonna say this aligns with what Patrick and Blue is kind of showing you. So it's like the question: how can these clouds still be lit by sunlight after sunset? So the reason why it's explained is because here, so you have an observer here has a direct line of sight. So the sun is above the horizon, but as the sun falls below the horizon, the clouds above still has a direct line of sight. So that's the reason why the clouds are lit, but the observer is is in the shadows now. So we can actually time this, and it falls within reason that the Earth being a sphere. And the reason why we see in sunset is a sunset just means that the Earth is rotating away from the sun for the observer. And of course, sunrise is the sun is rotating towards the sun for the observer. So that's all that is. So this is just a good explanation mathematically on how we can figure out exactly how high the freaking clouds are based on the time it takes for the sun to set and stuff like that. So
see the curvature of the Earth and the clouds based on your diagram.
Yeah, here's the curvature of the Earth.
Why don't we see it in Stash's PFP?
This is the same explanation.
No, why don't we see the curvature of the Earth along with the, what's casting that shadow?
When you say you don't see the curvature of the Earth, so you still see the curvature. So real quick,
below, you're claiming it's below the horizon.
Oh wait, are you asking? Are you asking why we don't see the shadow of the Earth in the sky?
Well, as far as the diagram is below the line of sight of the observer, so it's below the curvature. Which y'all claim is at the horizon.
We do see the shadow of the Earth on the clouds. It's called nighttime.
Where?
It's called nighttime. That's called night. What do you mean where?
You can explain that with a local light source. We're just farther away from the observer. Much farther away from you.
Actually, you can't. Actually, you can't. So optical. The reason why this is easy. So
all
take
light
any
is local,
spotlight,
including the sun. What are y'all talking about?
Take any spotlight. So you can go to like a play. Say you went to like a play at a theater or something like that. They can cast a spotlight onto the stage, and you still being in the crowd, and the audience will be in the dark, right? So if the Earth was topographically flat with a local sun, there should be no reason why you couldn't see the sun, even though it was moving further away. A lot of people try to use a flashlight as an image and saying like, see, this is the dark part. This is nighttime. But even still, that observer can still look towards the light and still be able to see it if the Earth was topographically flat. The problem is we don't experience that. This is a better explanation for why we see what we do and why we have a sunset and sunrises and stuff. You wouldn't see a sunrise or a sunset on a topographically flat Earth with the local sun.
Are we on the same page that the shadow of the Earth is called nighttime?
Yeah, it's because the Earth rotated away from the sun. Yep.
We are. Also, I believe BFP had a question for optical that never got answered as well.
Yeah, that's all I wanted to show.
Well, I say, Navi, we can use your picture.
You give an explanation for a globe again. You just did the same thing. You didn't necessarily give an explanation. And didn't even let me respond. Like, y'all just want people to ask me questions.
Okay, respond. Well, how is that wrong?
Right, so as far as, say, there was I would say, a 100 square foot warehouse that was, let's just say, 5,000 feet tall, right?
Yeah.
And there was a light in the dead middle of that warehouse that was 1,000 feet off the ground. You think if you were at the edge of that warehouse 10 miles away, you think you would see that light?
Yeah. Where you're standing won't be illuminated, but yeah, you'll see the light.
Right.
Is there any object blocking my view, or if there is nothing blocking the view?
It's kind of like a stage. Like the artists are illuminated, but you're not. You still see the light, but the light's not focused on you. So I get your point. Yeah.
Yeah. Can I get back to my question?
Right. So that's what I'm saying as far as like the light. Yes. Even if it's a very, very bright light. So even if it was just say 100 miles away, you wouldn't see the light, right?
You still would see it. As long as there's nothing blocking it, the light is sufficiently bright, you'll see it.
100 miles away, you wouldn't see a light.
If there is
anything in front of it?
That's 2,000 feet up in the air.
Optical. Can you see stars?
See stars? Can you see anything beyond the horizon?
No, I'm asking you, can you see stars?
Is this assuming that the stars are a trillion miles away?
No, they're further than 100
because if he's asking me a question as far as can we see stars, of course we can see stars. That's going to lead to, well, if we can see stars that are billions and miles away, then we should be able to see forever. It's like, I don't want to go through that on that route.
Optical, are stars further away than 100 miles?
Go. I don't want to go there.
Are they?
Like
they're not.
Two different comparisons we're looking at this.
No, they're the same
it's a
thing.
light source.
You said you can't see a light if it's more than 100 miles away. I said you will see it if it's sufficiently bright enough and nothing blocks it.
That are able to be seen at these great distances. There's no evidence for that. Like, I don't.
But is it more than 100 miles?
I just gave you evidence.
That's the question.
Just gave you evidence.
This comes back to the question that I think Owen is trying to get in here. So let's get Owen to ask that question without him getting interrupted.
Does light unobstructed go in a straight line? Okay, so the light cannot be bending from a light source higher than the shadow and cast it upwards.
Keep saying it can't do that when it can, right? Like,
do you not hear how that doesn't work? Like, do you just not hear that?
Show me. Take a light above an object and cast a shadow up.
And then tell me where that light source is. Because did you literally agree with everything we said and then just say nope? Because otherwise it wouldn't fit your model and your narrative, dude. Like, this is getting absolutely absurd at this point. You know what you need to say and you know what you need to believe, but it crumbles your little pancake world. It doesn't fit with reality, bro. You've got everything nailed down. You know the answers. You just want to reject them to believe in a flat earth. This is ridiculous, dude. But now you're in a big box. Go ahead, pull out a light, use an object, and show us how it'll work on a flat earth. I just did it with my phone and my vape. So why can't you show me with something else? Like, I don't know, your phone is something else.
Use your phone and maybe like your neighbor's cat or something.
Yeah.
Or your fists.
Don't put cats into danger here.
No. Don't put it in danger. You gotta, be nice to it.
Yeah, exactly.
Talk sweet to it.
Right. So I see the reflection of your hand on the table.
I was on mute. My fault, y'all. So the light, right? This is reflective, though, but don't worry. At the same time, I'm gonna try to set my phone down. Hold on.
You have multiple light sources in there.
Can y'all see y'all can see the under the table?
You need a single light source, though.
Hold on. Can y'all see under the table?
Yeah, we can see under the table.
Okay. You see the paper? My finger is under the table. The light source is above the table. And you can see my shadow on the paper. You see? You seen the light source. You see it.
So
it's
I can't see much. Can you move the camera?
No, wait. I understand what you're saying, optical phenomenon. The shadow is being cast on that paper by the table.
Huh?
The shadow is being cast on the paper by the table.
You said the light source has to be above something, which is above the table, and have the shadow under it.
Good. So you have one object blocking the light, correct?
A table blocking the light?
Yes, that table is blocking the light. Good. Now, if you look at the shadows from Master Blue, you can see the direction at which the object is. It's not up, it's down.
Under for the light above something, and I recreated what you wanted, and now you're trying to explain it away.
So if I did the same thing you just did with my laptop, which is also a dark object, if I did the same thing, you do realize because
what we both see in the sky, we both would see that. If I was standing next to you,
hold on, dude, you just love to overtalk. Hold on, brother.
So if I took a laptop and I closed it right now, and I did the same thing and left my lamp on and tried to do it with my light, do you know what would happen? I would still see a shadow underneath the laptop. Do you know why? Because washout in the room, the white walls, the white carpet, the reflection off of things. You understand that, right? We can
address that. There's nothing reflective enough to cast that shadow upwards in the area.
To the earth, like what's happening on the ground.
So now I want you to tell me what in Indiana. I pick up a map. I don't care what map you use. Tell me in Indiana what this would be phenomenal. This could be great. Tell me on a map what body of water would cause a reflection like that. I'll wait. I'll give you time to look up a map. Go ahead. You're talking about reflections and things bouncing off. So go ahead.
Trying to run away from it.
No.
I'm holding you down to what you said. Yeah. You said prior with what you were using to try to say there's a reflection because you can still see the shadow. Tell me a body of water in Indiana that would reflect that. Tell me, because you can't. The light source has to be below. No, because what you're not understanding, I have to go show, babe, it's okay, sweetheart, hold on. You're not understanding that there's no body of water that's going to reflect this. You're not understanding the light source needs to be below the object to cast that shadow into the sky. It's not hard. You just refuse to believe it because it ruins your pancake world. And we still good.
You said casting a shadow upward with the light source above something, above the ground. You said, how can you do that? And I showed it, and that was a problem. Yes. What are you talking about?
No. The issue is that it was addressed. You showed us a reflection. I agree. What you showed us is the light reflecting off the ground, casting your shadow upwards onto the paper.
No. Wait,
I've been quiet for so long.
No, I showed it with a white piece of paper.
I myself have been quiet for as long as I can, letting you guys go back and forth.
Did you not see the white piece of paper?
Yes, that's what I'm addressing. You showed us. I'm agreeing. What you showed us. Yeah, your shadow was on that paper. Boom, man. Good job. I agree. The issue is, I already addressed that at the beginning.
That's not a reflection. Don't be muting me. Yes.
I don't have the ability to mute people. I didn't do it.
Me either.
Yeah.
I'm just saying.
So the issue is that you, and Master Blue also brought it up, you do have a lot of other sources that are reflecting the light. So in Indiana, where he is showing this picture from, where exactly is the surface that would be reflective enough to cast that shadow the way it is, right, onto the clouds? But more importantly, why is it flipped? We need to address that. Even when your shadow was underneath the table on that paper, the shadow didn't flip. Again, we're seeing this outwards angling of the shadow. It's diverging away from the object.
Bro, and that's from below the clouds.
Hold on, for yours.
There's another
perspective. Yours, which you showed.
Above.
Yes, this is perspective. You're correct. And the perspective is showing us that object, the shadow coming off of it, is diverging outwards and away. Versus with the one you showed, where the light's reflecting off the ground, onto your hand, onto the paper, it didn't flip it. Because at that point, the light's still coming from underneath. You need to be able to flip that shadow to get the same effect. This is a primary shadow. This isn't some secondary one happening off a reflection. I agree. What you showed is the light source above casting, you're allowing a shadow to be created. You're just not accounting for the fact that light is reflecting off of other parts of your room. I agree. What you showed is fine, but it doesn't address the main concern of what we're showing here. You need to flip the shadow. Same with the Mount Rainier one, where it was even more exaggerated. You see that triangle shape even more so than in Master Blue's.
I can still see a shadow casted on here because it's bouncing off the carpet and the walls. Dude, it doesn't help you. It doesn't. Why do you think I turned off all the lights and brought out the one light source that we needed to show you exactly how this happens, man? It's not... I eliminated the washout.
One light in here. That's the only light down here. What are you talking about?
You had other lights, like the LEDs that are up on the side. And I don't know if you can turn those off easily. So, I don't really care. I see how you might have thought that answered the question.
What are you talking about?
When you turned on your camera,
it wouldn't matter because the light. You asked for the light source above it. What are you talking about? Above the something that's blocking you?
Yes, so you have a lot of ambient light in the room that is also not helping. But more importantly, again, you weren't showing us the flipped shadow that we need for the light source to be, the light source below the object. You were showing us, you were showing us one where the perspective is flipped to the other direction than what we need. Where the shadow was larger towards the object and got smaller the farther away it was. That's what you showed us. We need the shadow diverging outwards, getting larger, because the light source is below the object. That's the only way it works.
Like, it's not a difficult concept, my man. It's really not. It comes down to one very basic thing is the sun's below that object to cast it upward. If you're doing a movie set and you needed a shadow to go upward, where would you need that light? Below it to cast it up. Same thing on Earth. Again, I don't care whether it doesn't matter whether it proves it's flat or not. Your local sun has an issue here.
Light. Does anyone want to see me cast shadows?
Are you a wizard?
Cheers.
Just make sure it's a PG shadow.
Ball first, hold on.
Where's Josh at? Josh, are you still here?
My fault. Turn the LEDs off, okay?
Okay, white walls, clothing, reflection. Dude, you have so much.
Don't matter. It's stuff on the ground. You got grass, grassy lands, all that, houses, everything.
You're already
doesn't reflect
rooftops.
You're already disproving yourself because the bottom of the table is lit.
No, bro, what you talking about?
Do I need to get a point source for you?
The bottom of the table is lit.
Yeah, you don't understand.
I can get just a point source of light if we need. Like, even though Master Blue, I'm not even gonna do it. Master Blue already fucking did.
I went through the struggle.
Yeah, there's no point in me doing it if it's already happening.
The bottom of the struggle. So how you see the different colored clouds? Hey guys,
I just told you the different colored clouds is very simple. It's because Rayleigh scattering, the more the light has to travel through the atmosphere, the different wavelengths of light that it hits to your eye. It's very simple. The lower it goes, the more red it gets. Even sometimes you get that blip of green, but that's a whole nother conversation we're not even going to touch on because that's a whole nother thing. It's rare to see. But the lower you get, the more orange or red that light will get. The higher up it goes, the more orange to yellow to white it will get.
Color, how it changes is the fact that you can see it, right? That's what I'm talking about.
No, it's
you see
the more it has to travel through the atmosphere.
You see the obstruction of the light.
So what you're not understanding is but you asked about the color of the clouds, and I'm trying to tell you, dude, that if the sun was staying up where it's at in the sky, you wouldn't have that same gradient because it would still be where? Going through less atmosphere, but where's the sun at?
Upwards with the light source.
Higher. If the sun is up high, how can it travel through more atmosphere? If it stays up local, how can it travel through more atmosphere?
I gave you what you asked for.
Optical. Let me show you something.
Didn't. You're just being ignorant on purpose.
Let me show you something that I just did.
How does the shadow go up with the? It got to be a light source below it. You asked me to show you, and I did that.
No, so
no.
Yeah, so you didn't show that. Here, I got a big torch.
Wait.
Just like
let me show you. Let me show you something I did with what Master Blue gave me.
All right, so here's my torch. I'll let you go first.
It's pretty quick. So he gave me a date, and because of that date, I got the angle the sun is setting is 285 degrees west northwest. Then I checked Indiana topographical map, and he told me he's right here, so he's west northwest. I'm not familiar with the geography of the United States, but then you have Illinois west northwest from that area over here. Look, you have mountains here on the topographical map. And then I went and I checked satellite data to check the clouds that were on that area. So right here you have the Great Lake. He is right here. He's looking into this direction. You see this big cloud over here. It's the same Right here, you have the cloud that is looking at, and the shadow is being cast by the mountains that are on this direction. Yes, explain to us what is the object that is floating on the sky and blocking that shadow and causing this. Had the sun up, the table, and then the observer, your piece of paper. So table on Master Blue picture. Thank you.
Mount Rainier being seen from